Now let's continue by switching over motor acceleration analysis and run a simple static or dynamic motor start analysis. Let's begin with running a simple static motor start analysis. As you know, before starting any analyzation in terms of motor starts, we need to have a set of events in which we're gonna describe in this event at this moment of the time. We're gonna have some of the loads which will decide and a group of the loads adding to the existing one which are up and running. So in order to make those events, we have to create them by clicking on the edit study case and switching over event tab. And as you can see on the left side, we have to add the new event. We have to create the event, and the first one I'm gonna put Eve on, which is gonna happen or occur at the second one, and click on OK. Now that we created the first event, we need to describe what sort of actions we're gonna have by the occurrence of this event. So let's say on first second, we're gonna have all the rest of the loads or existing loads coming online. That means motor 1, 2, 3, and 4. All the 4 motors, existing motors that are on the line before starting the new loads. And let's, for the total simulation time, let's put 10 seconds and click on OK. So when we run the static motor starting analysis, the alert view window will pop up which says which of the loads and which of the buses are in the critical or marginal region, which like in this case, we can see what buses are in the critical area, which are below 90%, and what buses are in the marginal and at the second in the time. Another thing, we have this time slider. By sliding it forward, and let's say at the first second was when the event 1 happens, and before that, as you can see, we don't have the flow of anything inside our system, and right on the first second is when all the motors start, as we define this event on our E1 event. And after the first second, 20 milliseconds after, we will see that the rest of the motors, except the new ones that are not yet on the line, will go back to their steady state mode and not in an inrush moment. So static analysis would not have the flexibility as a dynamic analysis does, but what we can achieve while running static is that in those events and those moments of time that we manually define the system, we will see how the system reacts. So it's like those pinpointed seconds in the time, among the duration of the simulation time, we will see the reflection of the system. So now let's again go on the edit study case and add the second event, which is when we want to say event 2 is happening at the fourth second, but this time we're gonna have air compressor number 1 and air compressor number 2 coming on the line as well. Now let's again run the static motor analysis. This time, as you can see, at the 4th second, we will see that we are under voltage and we are in the marginal area because of these two compressors coming on the line. In order to have a better image, as you remember, we have the motor starting plot feature, which using that we can use our device type, and in this case let's use the bus voltage, and let's choose the main bus or bus 2 voltage levels throughout the whole simulation time. ETAB would give us the plot of the main bus or MCC bus voltage throughout the 10 seconds of our simulation. As you can see, at the 1st second, the voltage would drop down to 90%, around 91% of its nominal voltage, and at the 4th second, we will have the 2 air compressors added to the line, which again will have a side effect of bus voltage dropping down to 96, 95, 96%. So you can go ahead and try different options and different events, sets of events to do your study on your system to see, after adding this burden on the line, what would be the reaction of the system, if your bus would tolerate this kind of inrush moments of the loads or not. So in order to run the dynamic motor start analysis, we will need to have the model of the motors and some other characteristic of the motors, like what kind of a load is attached to this motor and what kind of inertia and what is the inertia of this motor and the load. And in order to run this dynamic analysis, you can go back to the motor start analysis chapter of this course and step by step run it in order to get the motor starting curve using the dynamic motor start analysis.